Next, we're going to be talking about Chapter 5, which is all about the integumentary system. So, you might be familiar with the integumentary system, especially your epithelial epidermis, but maybe not the connective tissue dermis. That's what we call the integument, which sometimes is nicknamed the skin. And the integument is mostly connective tissue. It is connected to underlying tissues by the hypodermis, which includes fibrous connective tissue and fat, and that hypodermis is also known as subcutaneous tissue. But what else is in the integument? Well, the integumentary system consists of skin, hair, nails, sweat glands, and sebaceous glands, also known as oil glands. When we're talking about the skin, we always start with the epidermis, that dry membrane that you can touch. It consists of 4 or 5 strata or layers that make up the stratified squamous epithelium that we call the epidermis. Now, it's a dry membrane, it's mostly keratin, especially at its apical surface where it has keratinized or essentially dead cells. Thick skin is a type of skin that's different than thin skin, and it's only found on the palms and soles of the feet. And it actually contains all 5 strata, whereas thin skin only contains 4. Hence, me saying it's only 4 or 5 strata for the epidermis. It depends. If you're looking at thin skin, you're missing the layer called stratum lucidum that's only found in thick skin. And thin skin is much more common, it covers most of the body, and it's going to be the skin that contains hair follicles. So let's look at thick skin just so we cover all of the layers. But note what we don't see in the image on the right, no hair follicles, because it's not in thick skin, only thin. So here we have the 5 layers of thick skin. You have the most superficial stratum corneum, and then underlaid by that, stratum lucidum. Both of these layers consist of dead cells because they're too far away from the base layer called stratum basale, which is close to the dermis, and the blood vessels needed to provide nutrition to epithelial cells. Under stratum lucidum is the first living cell layer, stratum granulosum, and any cell above this layer, again, dies. And then you have stratum spinosum, and then finally at the bottom, stratum basale. Stratum basale is the only layer that is still mitotically active. So these cells in stratum basale close to the dermis are actually able to perform mitosis and produce new epithelial cells. These young keratinocytes, which is the most common cell type in the epidermis, then move upward into stratum spinosum. The layer of keratinocytes that are in stratum spinosum are connected to each other by desmosomes. And when you stain the epidermis, that kind of makes the cells shrivel, and we can see those desmosomes connected to other cells. That gives it the appearance of kind of spiky or spiny cells. We also find melanocytes in this layer, and melanocytes are going to be cells that produce pigment called melanin, and that can change skin pigment. Everyone has about the same amount of melanocytes, but those melanocytes produce more or less pigment. Above stratum spinosum, you also have the granulosum layer. Granulosum layer is mainly going to have quite a lot of granules, both keratohyalin and lamellated granules, which will help give rise to keratin and some waterproofing in the upper layers. So it really is stratum lucidum above granulosum that allows for some waterproofing. Again, this layer, stratum lucidum, is only present in thick skin. And then stratum corneum is the most superficial, the thickest layer of the strata, and it's anywhere from 20 to 30 cell layers thick. It does help with protection, prevents penetration or abrasion, provides some mechanical and chemical barrier to infection, but it's mainly just a thick layer of dead cells, so it is mostly protective. Other cells you might see in the epidermis is the Langerhans cell, also known as a dendritic cell. This is an immune cell that patrols the epidermis, generally found in stratum spinosum. Under the epidermis, you have the dermis. So it's deep to the epidermis and is made up of 2 regions, both of connective tissue. The top region just below the epidermis is the papillary layer, which makes up 20% of the dermis. So it's the most superficial, and it actually contains peg-like projections called the dermal papillae. And things you could find in these dermal papillae are capillary loops, touch receptors, or maybe just free nerve endings. You can also find touch receptors deeper in the reticular layer. This deep reticular layer makes up 80% of the dermis, and it's made up mostly of dense fibrous connective tissue. So it has collagen fibers, and it also has some resilience and stretch and hydrates the skin. The dermis also contains blood vessels and nerves and hair follicles and hair follicle roots, like blood cells, glands, muscles, mechanoreceptors, like I mentioned before. So a lot of the stuff that is in the skin actually occupies a good amount of space in the dermis. So one thing we're going to see in the dermis is glands. One type of gland is sweat glands. They're also known as sudoriferous glands. There's two types of sweat glands, ocrine and apocrine. Apocrine glands are bigger than ocrine glands, but they both have a coiled tubular structure, and because they're both exocrine glands, they have ducts that proceed towards the surface of the skin. But only ocrine glands have a duct that actually goes to the surface of the epidermis and forms a pore. You can find ocrine glands all over the body. Whereas apocrine glands, they are found not all over the body, they are found only in the armpits or axillary region and the anogenital region. They begin functioning at puberty, and the sweat they secrete is a little bit thicker than that from ocrine glands. And their duct actually goes to the space that's right next to a hair follicle. That space next to a hair follicle is known as the biliary space or biliary canal. So that's where they send their secretion. Sebaceous glands, though, are going to be a little bit different from our sweat glands. Sebaceous glands are also known as oil glands, and they secrete sebum. Their shape is sac-like, or that's called alveolar. They also have a duct that goes to that space next to a hair follicle, just like our apocrine glands that produce sweat. But the sebaceous glands that produce sebum or oil, they are going to produce that next to a hair follicle in order to lubricate the hair. That can also move towards the surface of the skin from that biliary canal and lubricate the skin, but that oil can also inhibit bacterial growth. And some other glands just to mention are ceruminous glands, which are modified apocrine glands that produce cerumen. Cerumen is earwax, so you find these glands in the ear canal. And the mammary glands are specialized sweat glands that secrete milk. All right, now we've made it to the hypodermis. The hypodermis is subcutaneous tissue, means the same thing. It's not necessarily a part of the integument, but it is under the dermis. So it's sometimes called subcutaneous tissue because it's deep to the cutaneous membrane made up of the epidermis and dermis. Just like the dermis, it's both vascular and innervated, but it's made up mainly of some connective tissue and fat. Next, we're going to be looking at hair. We're just going to look at the very basics. So the functions of hair is to maintain warmth, alert the body to an insect being on the skin, help prevent physical trauma. It also is going to keep heat in, and it also helps protect against sunlight or UV rays. Hair is distributed all over the skin except in a couple of places. It's not on the palms or the soles or the lips, so we never find it where there is thick skin. It's also not in the nipples or portions of the external genitalia. And in general, there are two types of hair: vellus hair, which is pale, fine body hair, and terminal hair, which is coarse, long hair of the eyebrows, the scalp, your armpits, the pubic regions. And when we look at a hair follicle, it has two general parts. It's going to have a hair root and a hair shaft. There's generally a hair bulb down at the bottom of the hair root where you have a capillary bed called a capillary loop in a dermal papilla, and that's where you're going to see cells very close by of the hair itself be able to still perform mitosis and allow for hair growth. We also have three layers to the hair follicle itself: an outer cuticle, an inner cortex, and an airy space called the medulla in the middle. So that's really it for the hair. We could go into a lot more detail, but we're just hitting the basics. Next, we're going to hit the basics for nails. So for nails, we want to know they are a modification of the epidermis. The part you cut is called the free edge. The body of the nail is the part you don't cut, but it's also in between the free edge and the cuticle. If you were to press down on your nail, it's the pink part. That pink part is actually due to vascularization that is under your nail, and that's coming from the nail bed. So that's again directly under the pink part of the nail. Some individuals have a really prominent lunula, which is a white semicircle on the nail, and luna means moon, and the lunula generally looks like a white crescent moon. The eponychium is your cuticle. The hyponychium is under the free edge that you cut. It's essentially the area where dirt can accumulate. If you've ever cut your nail too short, that's kind of where you start to experience pain. And then we talked about the nail bed, and then the nail matrix is something you can't see. It's under the cuticle, so it's past the root of the nail, which is also under the cuticle, and wraps around it and is an extended part of the nail bed where cells are still mitotically active or performing mitosis, so it's responsible for nail growth. All right, next we're going to finish up talking about different types of skin cancer and then also other things that can affect the epidermis and affect the skin, like burns.